So let's have a look at this example of an ellipse. We are asked to find all the characteristics of the graph with equation this. Now, to identify whether this is firstly an ellipse or not, this is since in the general form, we can do some simplifications. We can divide everything by 36, and what we would get is x squared over 4 plus y squared over 9 is equal to 1. Now in this case we do not have any shifts, it's centered at the origin, but if we did, we might have to complete this square. We would have to complete this square if there were other terms. In this case we have been able to avoid that. So this is simplified to, we can see 2 squared plus, like we're trying to bring it to the general form of an ellipse, the standard form. And we remember that a must be greater than b. That's the format, right? So this is how we would instead look at it and define these constants. So this is an ellipse. There's a plus sign here. A minus would mean that's a hyperbola. So we have a is equal to 3 and b is equal to 2. So let's go ahead. Let's firstly, I think we can sketch a quick graph of this since we know these things. So if we have the ellipse centered around the origin, this is the vertex, right? So this is like 3 comma 0, and this is like negative 3 comma 0. Sorry, I've kind of done it the opposite way. So what I mean to say is this is on the y-axis, and that's the major axis, right? So 0 comma 3 and 0 comma negative 3. And these are the co-vertices, which are at negative 2 comma 0 and 2 comma 0. That's the minor axis now, and that's represented by b, if you remember. So let's go ahead and define all of these quantities. The center we know is clearly 0 comma 0, since there are no shifts to this equation. H and k are 0. Then we have the vertex, or the vertices in plural. We have them at these points, right? It's not the co-vertices. This is 0 comma plus minus, we had plus minus a, right? So a here is 3. These are the vertices. And then let's go ahead, before finding the foci, or okay, we can write the co-vertices. So co-vertices are at plus minus 2 comma 0. Now as you can see, we do have a shifted thing. Like here we studied the co-vertices as 0 comma plus minus b. But since the graph is in a different orientation now, we have plus minus b comma 0. So we'd have to be a bit careful about that. Let's go ahead and define the eccentricity. So that's 1 minus b squared over a squared. And this becomes 1 minus 4 over 9. B squared is 4, A squared is 9, right? So we have the eccentricity as square root of 5 over 3. So that's our eccentricity, and the foci are at 0 comma plus minus, if you remember, plus minus be. So this is 0 comma, if you multiply b with this, you would get a square root of 5. So these are the positions of the foci, and we can point them on the diagram. These are like the foci, right? It's a bit less in distance from the vertices. Now we have equation of major axis. Equation of major axis here is, since it's again shifted, x is equal to 0. The equation of minor axis is y equals 0. And finally, the length. So length of major axis, length of major axis is supposed to be 2a, right? So 2a, a was here 3, so we have a 2 times 3, which is a 6. Length of minor axis is 2b, minor axis, which is 2b, which is equal to, we have a 4. So these are my lengths. And finally, we have the equation of directrices, which were situated, in this case, it will be on the y-axis, because y-axis had the major axis, right? And the directrices would be situated right above and below them. So we have y equals plus minus ae, and that would give us y equals plus or minus square root 5. Finally, we have the last few things. Equation of lattice rectum, which is, pardon me, I've done a small error here. The y is here plus minus a over e, and so we have plus minus 9 over square root of 5. And for the next one, we have y equals plus minus ae, right? So this is plus minus just square root of 5. And length of lattice rectum, here would be again 2b squared over a, which is 8 over 3. So that's all of these points. Now, if we did have a shift of the equation, if we did have y minus k squared over some a squared plus, let's say, x minus 8 squared over b squared is equal to 1, well, we would again follow that same method. We would take the uppercase as the reference and then solve for the other parts, just like we did for the parabola. Now, you could do a sketch and find out these points, but yeah, that's also another way to go about being confirmed about each of these, since the x equals 0 is the major axis, y equals 0 is the minor axis. A sketch always helps in interpreting these questions.